All right, today we're going to talk about something most of us use every single day without even thinking about it, bottled water. We're going to peel back the label, look past all the marketing, and use some really cool new science to find out what's actually floating around in there. Let's jump in. So many of us grab a bottle of water because we have this idea in our heads that it's the clean option, it's pure, it's safe. Certainly better than tap water, right? That one simple belief is what fuels a massive, multi-billion-dollar industry. But what if it's time to take a closer look at that assumption?
So that's exactly what we decided to do. We put that belief to the test. We just went to a regular grocery store right here in Los Angeles, and we bought 7 of the most popular brands of bottled water we could find right off the shelf. Our mission was pretty simple: test them all for microplastics. But, and this is the key part, we didn't just want to see if they were there. We wanted to know what kind of plastic we were dealing with.
So, that brings us to the big question, right? Out of these 7 major brands, and we had a mix of plastic bottles and even aluminum cans, how many do you think actually had microplastics in them? Go ahead, take a guess. 2? Maybe 3? Hopefully none.
The answer was 7. Every single one. That's right, Dasani, Liquid Death, Fiji, Crystal Geyser, San Pellegrino, Evian, and Path. 7 out of 7 tested positive for microplastics. Not one brand that we tested came back clean.
So, yeah, that number is pretty shocking on its own. But honestly, the real story here is in the details. What did we actually find inside each of these bottles? Let's break down the data.
Okay, so here's the breakdown. This table shows what we call the relative fluorescence signal. Just think of it as a plastic score. The higher the number, the more plastic we detected. You can see Dasani in its plastic bottle came in with the highest score. But here's the really critical part. Our system identified the plastic in all 7 brands as PET. That's polyethylene terephthalate. It's the exact same plastic that water bottles are made of.
We all kind of think aluminum is the safe, plastic-free way to go. Well, what we found completely flips that idea on its head. In fact, the most surprising, kind of mind-blowing result of this whole thing came from the water packaged in aluminum.
I mean, just look at these numbers for a second. Liquid Death, which comes in that tall aluminum can, had a plastic signal of 141. And Dasani, in its classic plastic bottle, had a score of 143. They are practically identical. At first glance, that seems totally impossible. So what on earth is going on here?
Well, it turns out every single aluminum can has a little secret. There's a super thin PET-based plastic liner that's sprayed on the inside. It has to be there to stop the liquid from reacting with the metal. Our system was so sensitive, it picked up the unique chemical fingerprint of that PET liner leaching into the water, without us even telling it that it came from a can.
So at this point, you're probably wondering, okay, but how do you guys actually know what you're seeing? How can you tell one type of plastic from another? It's a great question. Let's get into the science of how this actually works.
The process is actually pretty slick. First, we take a water sample, and we add a special fluorescent dye called Nile red, which loves to stick to plastic. Then, we hit that sample with different colors of light, UV, blue, and green. And here's the cool part. Under those lights, different plastics glow in their own unique way. They create a distinct fingerprint that our system can read and then identify. Now, in the spirit of full transparency, we did not get this right on the first try. Not even close. Our first round of tests showed absolutely nothing. Just a flat signal, no difference between any of the brands. The problem, it turned out, was our dye was way too diluted. Once we switched to undiluted Nile red, boom, we got 1,000 times boost in the signal. We also learned that just using blue light wasn't enough, because PET and polystyrene looked exactly the same. But adding a UV light created this huge separation that let us tell them apart, no problem. And this right here is what makes this method so incredibly powerful. Our entire hardware setup, we're talking a Raspberry Pi camera, a few LED flashlights, and some filters, costs about $165. To get this same kind of data from a traditional lab, you'd need equipment that costs over $50,000, and they charge you up to $800 for a single test. This is what making science accessible looks like. So these results are really interesting, but we have to be clear, they are not the final word on this. To be responsible scientists, we need to put all of this into the proper context and be really honest about the limitations of what we've done so far. It's so important to remember that this is just the beginning. Think of this as round 1 of a 12-month-long study. It's a snapshot in time. For instance, right now, our system is fantastic at identifying the main type of plastic in the water, but it's not yet counting every single different type of particle. Also, that signal strength score is a relative measure for comparison between brands. It's not an exact particle count. We just want to be totally upfront about what this data can and cannot tell us right now.
And just to give you some more context, a huge study came out of Columbia University this year that found up to 240,000 plastic fragments in a single liter of bottled water. But get this, the most common plastic they found wasn't from the bottle, it was nylon, and they traced it back to the water purification filters used during the bottling process. The very system that was supposed to be cleaning the water was actually adding plastic into it.
This chart really helps put our findings into perspective. When we test tap water here in LA, we do see some particles, but the levels in these bottled waters are significantly higher. And when you compare it to lab-grade purified water, which has almost nothing in it, the difference is just night and day.
And like I said, this is not a one-and-done test. We are retesting these exact same bottles every single month for a full year. We've got them stored in a garage, to simulate how a lot of us might keep backup water for emergencies. And the big question we want to answer is, does the plastic contamination get worse the longer the water just sits there? You can actually follow along and see the new results every month on our website. Okay, so we've walked through the data, the science, and the bigger picture. But what does all of this actually mean for you? Well, the goal here is not to scare anyone. It's simply to provide you with the data so you can make your own informed choices.
And that's really what this is all about. We're not here to tell you what you should or shouldn't drink. We're here to share the information that we've found so that you can weigh the factors and decide what makes the most sense for you, for your health, and for your family.
Now, if you are concerned about microplastics, the good news is there are practical things you can actually do. A good reverse osmosis filter for your tap water can remove over 99% of them. Switching to glass or stainless steel containers is obviously a great way to avoid plastic leaching altogether. And hey, if you're curious, you can even get your own water tested and become part of this growing community science effort.
We started this whole project with a really simple experiment, just driven by curiosity. We've shared our data with you, our methods, and where we're going next. So now we want to turn that question back over to you. We've shown you what's in these bottles. What's in your water?